Hello again. My name is Miss Tiberio, and I work at Jane Addams Middle School, teaching 6th grade science. If you're not in my class and you're watching this to learn about weather patterns, I just wanted to reintroduce myself. So today we are doing lesson 1.6 in our packet. So you need your packet, or something to write on and something to write with. And I will wait for you to get your stuff. Okay. Last time we talked about 1.5, and you might have noticed that there were some animals over my shoulders, so I just wanted to take a minute to introduce them. This is Ruby. She is one of the class pets. And this is Izzy. And this is the other class pet. And sometimes they hang out with me and help with our learning, so they're going to be over here. Okay. So the reason that we write stuff down when we're doing these exercises is to help our brain process. And so if your brain struggles with writing, it's totally fine if you want to type stuff out or if you need to just sort of pause the video and then talk out loud so you can process your thinking. All right? All right, here we go. Lesson 1.6, Explaining Surface Water and Rain in Galetown. So our goal today is to look at some claims about what is causing the severe weather in Galetown, analyze some data, and try to answer the investigation question, does surface water impact the severity of the storms? Right? And we're going to do that by looking at the data, and then we're going to write at the end of our lesson. We're going to write some claim evidence reasoning to help us explain our thinking. So let's quickly look at the vocabulary just to remember what we're talking about here. So you'll see on the screen or on your packet our list of words from last time: air parcel, cloud, condensation, energy, evaporation, temperature, transfer, water vapor, and weather. So we're going to move on to our warm-up. All right, so here we go. Based on what we've learned so far, which claim would you support? What evidence have we gathered to support these claims? Okay, let's look at the claims. What caused Galetown to have more severe rainstorms? Claim number 1, the lake that was built near Galetown caused it to have more severe rainstorms. Claim number 2, warmer weather caused Galetown to have more severe rainstorms. Claim number 3, stronger winds caused Galetown to have more rainstorms, severe rainstorms. All right, well, those all sound like legitimate reasons why the rain and the weather could be getting worse. However, I feel like we've only really looked at evidence for the surface water, the lake. So I think that's the one that I'm going to write about. You can pick a different one if you feel like we've got evidence for other things. So you can pause the video for a minute and you can write down your thoughts. Okay, we're back from writing our thoughts. Let's check in with Dr. Kenji. He has gathered some data for us to analyze. Remember, he's the forensic meteorologist that has been studying what's going on with these storms. So I see in this chart, I see that it's got 4 storms listed. It's got storm 1 with some data, ta-da, right here, before the lake. Storm 2, 3, and 4 are all after the lake was built. So now I'm going to look over here at the local surface water, and I see before the lake was built, there was not very much surface water available. So that's low. But then after the lake, because there's a lake, right? Now we have a lot of surface water, so the surface water level is high. All right, now I'm going to look over here at the amount of rain. So I see that when we had storm number 1 before the lake, there was only about 6 centimeters or 2.4 inches of rain that fell during that storm. But the storms that occurred after the lake, I'm noticing that there's a lot more rain. 12.7 centimeters, 20.3 centimeters, 30.5 centimeters. Okay, so the next question in our packet is, what patterns do you notice? So take a minute and think about what patterns you're seeing. I'm seeing before the storm and after before the lake and after the lake was constructed. There seems to be a change in the local surface water, and also I see that there's a change in the amount of rainfall. After the lake was built, I'm noticing that the rainfall is getting more and more severe with each storm, but the surface water level isn't changing. That makes me think that maybe that surface water isn't the only thing that's contributing to the severity of the storms, but I'm definitely noticing that Storm 1 had less rain than all the other storms, and that was before the lake was built. All right, so hopefully you were looking at the data as well, and maybe you came to the same, or maybe you came to a different conclusion based on what your interpretation of the data was, and hopefully you've filled out some of this packet. What patterns do you notice? And also the question, do you think increased surface water leads to increased rainfall? So that data table could provide evidence to complete those two sections. All right, so our next activity is going to be to look at these images and write in on this chart or this diagram what's going on that's causing the different rainfall. So what am I going to do here? My goal is to show the amount of surface water and how it caused the different amounts of rain. So I see that there's a before and an after. And down below on our packet, it gives us some instructions. So we're supposed to label the model, Storm 1 or Storm 2. Okay. Well, I look further down and I see that there's a table. Okay, there's a table down here that's talking about some data. So Storm 1, low surface water, mild amount of rain. Storm 2, high amount of surface water, moderate amount of rain. So I get to pick if I'm going to diagram Storm 1 or Storm 2, and then I'm going to follow these steps. I'm going to label it, right? I'm going to label it Storm 1 or Storm 2. I'm going to show the temperature of the air parcel and the surrounding air. I'll show the amount of water vapor. I'm going to show the direction of the energy transfer using arrows. So think back to the sim. Remember when we saw the arrows kind of going out to share the energy from the inside to the outside? So we're going to draw some arrows in. The amount of liquid water inside the air parcel, the amount of rain, and the amount of surface water. Okay, so we have a checklist here. We're going to put all of these things into our diagram to help us understand what's going on, what the difference is between Storm 1 and Storm 2. Okay, what am I going to use? Oh, look, right here it says, ta-da, I'm going to use the words high or low. I'm not going to use numbers. I'm going to use high or low for temperature and for amount of surface water and amount of rain. Okay, so you're going to go back up to your image here, right here, and you're going to put in the before, you're going to fill in surface water, you're going to fill in water vapor, temperature in the air parcel, and temperature of the surrounding air. And then after, you're going to fill in how much liquid water is falling, what's going on with the temperature inside the air parcel, and what's going on with the temperature outside the air parcel. All right, so you're going to pause the video right now, and you're going to work on this, and then you're going to come back and check your answer, and I will wait for you. Great, so let's look at the diagrams that I did of Storm 1 and Storm 2, and see if they match what you came up with. All right, so the top image here was Storm 1, low surface water, and a little bit of rain. So what I wrote is, okay, we have a low surface water amount. Our temperature in here, our temperature in the air parcel is usually higher than the temperature outside the air parcel. We learned that from the sim, right? If there's going to be any rainfall, there has to be a change in energy, a change in temperature. So I wrote high and low for the temperature, and then for the water vapor, I wrote low, and then I drew my little arrow out. And then over here in the after, I drew a little arrow down for a little amount of rain. We have a low amount of water vapor, and now the temperature is low inside the air parcel and outside the air parcel. Because remember, one of the things that happens when the rain is falling, the air parcel rises up, the temperature inside transfers its energy outside. The transferring of the energy, right, causes the water to condense, and then it falls. So that was what I did for storm 1. So for storm 2, we have a higher amount of surface water. So down here by the lake, I wrote high. And then the temperature inside versus outside is the same. So high inside, high and low outside. But our water vapor amount is higher. Why is it higher? Because we have more evaporation ability because there's the surface water that's available. And so because we have more water vapor, we can have lots of rain. Yay, lots of rain. All right, here's your writing assignment. You're going to use evidence that you were given to write a short explanation supporting the claim the lake that was built near Galetown caused it to have more severe rainstorms. Tools at your disposal. There's a word bank. There's some transition phrases listed. And when we write a strong claim evidence reasoning, we're looking for 3 pieces of evidence. Depending on your learning, because this is practice, you can decide if you're ready to write all 3 pieces of evidence or if you need to start with 1 or maybe 2. All right? I'm going to write a complete claim evidence reasoning with this claim, 3 pieces of evidence, transition words, and some of the words from the word bank. And after you're finished writing, you can come back to the video and we're going to go over the one that I wrote and you'll compare. Okay, we're back. You have your claim evidence reasoning and here's mine. So we're going to look at this one together. I have color coded it. I have my claim in blue. I have my 3 pieces of evidence in yellow. I have my transition phrases underlined. I have my vocabulary highlighted in green to kind of give you a sense of how I followed the instructions. Now I'm going to read it out loud, and you're going to think about whether or not I did a good job. The lake that was built near Galetown caused it to have more severe rainstorms. The data collected by Dr. Ken G stated that before the lake was built, the amount of rain that fell during the storm was 6 centimeters. After the lake was built, the amount of rain that fell during storms ranged from 12.7 centimeters, 20.3 centimeters, to 30.5 centimeters. This evidence suggests that the increase in available surface water contributed to the increase in rainfall. The data we collected in the sim activity showed when the available surface water was low, the water vapor level was low. And when the surface water level was high, the water vapor level was high. Therefore, more available surface water contributed to an increase in water vapor. The science behind this relates to the water cycle. When the water gets warmer, it evaporates and turns into water vapor. The sim also showed us when we set the air parcel temperature at 25 degrees and the surrounding air temperature at negative 20 degrees, the total change in energy was 45 degrees. This means when the air parcel temperature is higher than the surrounding air temperature, the air parcel temperature transfers energy to the surrounding air. When the air parcel loses energy, the water vapor condenses into liquid water, forming a cloud, until enough liquid water forms that gravity causes it to fall out of the sky as rain. Therefore, because the construction of the lake increased the available amount of surface water that could evaporate and become water vapor, the lake is causing the rainstorms to be more severe. All right, that's what I came up with. You can think about whether or not I answered the question, if you think my evidence and my reasoning was sound, and then you can think about how that compares to your work. All right, here is the quick self-check for understanding that's in your packet. I feel like the lake has increased the amount of rain. I feel like we've looked at some evidence for that. I understand how transfer of energy causes water vapor to turn into rain. Okay, I feel pretty good about that. I wrote about both of those things in my claim evidence reasoning. I understand how warmer weather can affect the amount of rain. Well, I feel like maybe I'm getting there. I don't feel like we've talked about temperature so much yet. I do know that warmer weather, warmer temperatures causes more evaporation. So I can kind of see how that might be related. All right, that's the end of chapter 1. Thanks for joining me, and I will see you again in future chapters. Have a good day.